Hi everyone, this is Srihari. Today we will see how to use Hadoop on AWS, and that's by using EMR. EMR is Elastic MapReduce, which has Hadoop by default. So we'll briefly touch upon different types of pricing available in AWS, then pricing for each EMR or EC2 instance that we will be using in our demo, and also the price of Athena, and then we will quickly jump to the demo. Before we start, here is the architecture that we'll be seeing in the demo. So we will create an S3 bucket, load data to our S3 bucket. We'll initiate an EMR instance, query that S3 bucket using HiveQL, read and create an external table, then an aggregation table on top of the external table, and store the result back in S3 bucket in a different folder as a Parquet file. Parquet file is a compressed file which gives up to 90% compression and helps us save the S3 cost. We will then terminate the EMR instance, but since the metadata will be stored in EMR, all the metadata will be lost if we terminate EMR. Data will anyway be stored in S3, but the metadata will be stored in EMR. To avoid that, we will store the metadata in AWS Glue. So we'll see how to do that. Once the data is in S3 and we have terminated EMR, we can then proceed to query our tables from S3 using Athena. Athena is a serverless architecture, software as a service, which uses Glue metadata to query data in S3. Once we can query our aggregated table data using Athena, we can create some insights or reports using AWS Amazon QuickSight. Amazon QuickSight is a BI tool provided by AWS off the shelf. So this is the overall architecture. These are the services we'll be using in demo. The S3 for storage, EMR or EC2 to read and process data from S3, security groups as a firewall for EC2 or EMR cluster, Glue to store Hive metadata, Athena to query data from S3, and finally QuickSight to show reports using Analytics UI. Here are the different types of pricing for EMR or EC2. We must know this before we initiate an EMR instance as to how costly it will be. Free tier is not applicable for EMR, as T2 Micro is not available for EMR cluster, so you can't use that. On demand is when you pay per hour, and depending on the type of server, the region, it will vary. We will see how to use that. On demand is most commonly used if you are planning to use EMR for lesser than 1 year, maybe 6 months. Reserved is where you use for more than 1 year, so you pay one-time discounted price. It will turn out to be much cheaper. Spot is when you bid for unused capacity. If some big company has thousands of servers and they are experiencing less load, so they rent out their servers for a very cheap price. This is the best approach to do if you have not so mission critical application. The best would be to use on demand. If you are using a 5-node cluster, use 2 on demand and rest 3 spot. It will turn out to be much cheaper. So we'll first have to see what are the different EC2 instance types we have, how much is the RAM, CPU, what is the network bandwidth for each, and then equivalent pricing in EMR. Let's see the EC2 instances first. So here are the different types of EC2 instances: compute optimized, general purpose, memory optimized, accelerated computing, storage optimized. The type of server will depend on how much CPU, RAM, storage, and network performance it gives. So we will be using M5 series, which is the latest, and we'll be using M5 X large. Since ours is a very small data, we can use M5 X large. So M5 X large will have 4 vCPU and 16 gigabit of RAM. If you are using terabytes or petabytes of data, you might have to go for M5 24X large, which has 96 vCPU and 384 GB RAM, and you will have to use multiple instances of this server, a 5-node or 10-node cluster, depending on how soon you want the result. Now, once we know the type of server that we are going to use, we will have to check the pricing for this. So let's jump to EMR pricing. So this is the pricing sheet we have. The pricing varies depending on the region, and also the availability of server is also dependent on the region. Not all servers are available in all the regions. So you see M5 large is not there. It starts with M5 X large, which we'll be using for demo, and the cost is around 0.192 EC2 price, and EMR price is $0.042 per hour. So together it's around $0.2 per hour, which is fairly cheap. Now if you're going for a high-end server like M5 24X large, it will cost you around $4.3 to $4.4 per hour. And if you are using multiple cluster, 10 nodes for example, you will be paying around $40 to $45 per hour. To make it cheap, you go for spot instances, which will be 90% discounted on top of this. Now that we know the pricing and which type of servers to use for our EC2, let's get back to the demo. Here is the flow that we'll be going through for our demo. We'll create an S3 bucket in US East region. Then we'll load a sample CSV using AWS CLI to our newly created bucket inside a folder. Then we'll create one instance of M5X large EMR in the US East region. We have to make sure both S3 and our EMR is in the same region, else there will be huge cost for data transfer between the region. Then we log into EMR using a key pair. Once we log in, then we'll create an external table of the data we have in S3 using HiveQL, and then we'll create an aggregated table on top of it and store the result back in S3 in another folder. We will also try to query the aggregated table via Hue and Athena, and once it's set up properly, then we'll create a chart from the aggregated table using AWS QuickSight. This is the AWS management console. So first we'll create a bucket in S3, so we'll directly go to S3 for that. We'll create a new bucket called EMR-demo-123 so that it's unique. We'll click next. We'll click next again. We don't need any public access. We'll click next and we'll create the bucket. So our EMR demo 1234 is created. We'll create a folder here called input, so that our input raw file is stored here. Then we'll create another folder called aggregation, so that once we aggregate, we store the Parquet file in this folder. Now let's upload a sample file to this input folder. So I already have the sample file here called testseries.csv. This is a file where we have all the cricket teams and when the match was played, who won, who lost, or was it drawn, and how many of the matches were played. So all stats we have in this file. So let's load this. To transfer using command line interface, hold the shift key, right click, so that you can open the command prompt here. You need to install AWS CLI. That will be available online. Once it's installed, just give AWS configure. First time it will ask for access key, secret key, that will be available to you when you create a user. So if you have not created user, it was given to you by someone, then you need to ask your admin for access key and secret key. So this is already entered, so I'll just press enter. It will take the old one. Secret key region you have to specify. I'll keep the same, and the format can be none. So now once it's configured, you can directly enter AWS S3, copy test CSV from here to S3 bucket, which is S3 EMR-demo-1234/input. So we want to transfer this file, CSV file, into this bucket. It's copied. Since it's a very small file, it was fast enough, else it could take some time. Let's go here, click refresh. We should see the file. So we have the test series.csv file uploaded. Now let's initiate an EMR cluster and try to query this file. To do that, let's go to analytics, EMR. Let's create a new cluster. Go to advanced option. Here it will list the software that you can enable for installation. For example, since I'm doing it in Hive, I will use this, so I will check this. If you are trying to use drill, then you have to enable the zookeeper. If you want to use Spark, then you can enable this Spark. Presto, HBase, whichever you want to use in Hadoop, you can enable it here. This is the main thing, AWS Duke data catalog. Since Hive stores the metadata locally in DerbyDB, and once we terminate the EMR instance, that DerbyDB will also be deleted, and hence our metadata will be lost. So if we want to keep it somewhere, so we will use AWS Glue for that. And you just have to enable this for Hive and Spark, and that's it. In the backend, the configuration will take care of storing metadata in Glue. If you have to change some configuration, you have to enter here, but I'll keep it as it is. Hit next. This is the main screen where you configure the cluster. This EMR cluster creates a network VPC and a subnet that we don't have to bother. We can even say how much root volume we want, 10 GB is enough for me. And this is the where we specify the master and cluster node. So master node has to be minimum 1. The one install is already there. We can change the type of server from M5 X large to any other server here that's specified. Not all will be enabled by default. If you are using for the first time, you might have to contact support for it to enable that type of server, and even the number of servers. If you are using 5 node M5 X large, then you have to tell them that you will be using 5 node, please enable 5. Even on spot will not be enabled, you have to request support for that. I'll stick with M5 X large, which has 4 vCores, 16 GB memory and 64 GB of storage. Since I don't need any slave nodes, I'll make it 0. If you're dealing with terabytes or petabytes of data, you would need minimum 5 slave nodes. Another important thing is type of pricing that you want to go for. If you go for on demand, it will be the same as we saw in another screen, pricing screen. But if you want to go for spot, it will be up to 90% discounted, less than 1/3 for sure. So if it's not mission critical, I would suggest you go for spot instance. Since it's for demo, I'll go with on demand. Hit next. Give a name for your cluster, M1 M5 X large on demand, so that we know what kind of server we have. I'll disable login for now, and the termination protection is also not required. Another screen where you specify what kind of EC2 pair you want to use. So to log in, you need a file that's called EC2 key pair. I'll create a new one. I'll go to Amazon EC2 console and then go to key pairs, yes, and I create a new one and give it EMR -demo -2. So I'll download, since I'm using PuTTY, I'll download the PPK file directly. If you are using OpenSSH, maybe in Mac you will be needing OpenSSH, then you have to use PM file. I'll download this file. I'll go back here and create the cluster. So before that, I have to make sure I've select whatever key pair I have created, so that I can log in with this. Else it's of no use. Alright, this cluster is getting created. It says starting. We have to wait till it says waiting. It will give us a public DNS and all the UI connections. One more thing we have to note here is the security group, which is the firewall. If you are doing it for the first time, you will have to enable SSH port and other ports that you want to use. So click on that. We'll do only for master node. We don't need for slave node. We do it for master. So click on this, click on inbound, and here click on edit and add any port that you want to use. One thing you want to add is port 22 SSH, and another thing is 8888, which is the Hue URL. Since these both are added, I'll not do anything. So you have to give it anywhere if you want to be accessed from any computer, or if you want to be accessed only from office, then you better give a custom IP range. Alright, once you change it, click save. That's it. You don't have to worry about slave. We will not be accessing any slave node directly. So once the firewall is also set, we'll go back to here. So we have got the public master DNS, and other services are still getting enabled. We'll copy this master DNS. We'll try to connect via PuTTY. We'll go to PuTTY, give this IP address, go to SSH. So here authentication, you have to click and give the PPK file that we created just now. So EMR demo 2 is what we created. We'll try to open this. It's a passwordless login. The username by default will be Hadoop. That's it, we are logged in. Let's see how is the cluster. So we have around 10 GB of root and around 64 GB of rest. Let's see how much RAM we have. We have around 16 GB RAM. Okay, so let me try to create a table. I have the table structure here ready. So this creates an external table of the file we have in our S3 bucket inside input folder. Since first line is header, we'll skip that, and it's delimited by comma. So the file has these columns that we have marked here. So before that, we'll create a database called demo. We'll create this test series stats table inside this database demo. Using Athena also you can create external table, but you can't create a normal table. So I'll copy this. Put it here. And then let's see if our cluster is running. So it's still in starting state. Let's wait for some time for it to be up, else HiveQuery will fail. It takes around 5 to 10 minutes to start. Alright, it's up now. Let's go to our server. I'll say hive minus f. This should create the table as well as the database. Okay, it's created now. Let's go to Hue, click on Hue. So you see it runs at port 8888, and you have to enable this in the inbound of the security group, otherwise you will not be able to connect to this Hue. So if I refresh, I'll see demo as one of the database, and we have the test series here. So I can go click here, select from demos test series, limit 100. It should list us all the values. It's running now. Yeah, so here it is. We can see all the columns. Let's create an aggregation table on top of this with reduced value so that we can use that table to show an insight. So this is the aggregation table called test series ag. It only has team, opponents, the matches, result, and how many won, lost, and drawn. So it's not individual. There is no date component here. Copy this, paste it here, and run it. Okay, it's saying success here. So let's refresh. We are getting the aggregation table as well. Let's list the content of this table. Show details. So limit 10. Run this. So here are the top rows, and it shows the aggregated value. Now that we have those tables required already created here, we no longer need this. We can just click on terminate. It will get terminated. If you want to create another cluster with the same configuration, just click on it and click on clone. So you don't have to set everything again. Press create cluster. Now if you want to query, this Hue also will not be available. Now if you want to query, you can directly jump to something called Athena, which is under analytics. So this is the serverless architecture for querying files on S3. Here you can't create table, you can create only external tables, not aggregation table. So here we will select demo, and it lists all the files here, and you can directly say select star from. So this uses Presto DB, so there are a little bit difference in SQL compared to Hive, but 90% is almost same. So it's showing us the result here. That's it. Now you can use Athena to query as much as possible. Athena charges $5 per 1 TB of table scan. For example, this query that ran now scanned only 1.95 KB. So it's really cheap. 1 TB is too much, but depends on the data. If you have 1 TB of table that's created and you want to query that, Athena could be a little costlier compared to EMR. But make sure you don't give star every time, because it's a column based architecture. Give only the columns that you want as output. That way it reduces this table scan to a great extent, and you can save money as well. Finally, we will see how to create a chart using AWS QuickSight, which uses Athena as the backend DB. For that, we'll go to QuickSight, which is inside analytics. This off-the-shelf BI tool that Amazon provides. You can use Power BI, Tableau, but for that you need to create an EC2 instance and install Tableau there. So before you start, you have to make sure you are in the same region where you have the database created. Since it's showing Singapore by default, I'll switch to US East. This is empty. I'll click on new analysis, new data set. I'll select Athena as our data source. I'll give demo as the new data source, validate connection. So it's validated. I'll create this new data source. So it should list us all the database that we have created till now, and the corresponding table. I'll select the aggregation table. directly query the data and not store in Spice. Spice is something which QuickSight provides, I believe up to 1 GB of data provides for free. After that you have to pay. Okay, so it shows the columns here in the field list, and you can select the type of chart you want to see. I'll select this bar chart and I'll add opponents as y-axis and how much were won as value, which is a sum. Even how much was lost is a sum, and how much was drawn. So it failed for some reason. Let's see what. Okay, it's saying access denied. So the thing is, we have to give QuickSight access to the bucket from which it's querying. So to do that, we will go to manage QuickSight and then security and permission, and then add or remove, and go to Amazon S3 details, select X3 bucket. Here it will list all the buckets, but since our data is in EMR demo 123, we have to check this. And you can give write permission also if you want, but right now there is nothing to write. I'll say finish update. We have given the permission to the bucket. So let's see. So I'll add again, it's running again. Yes, now we can see the value. So as simple as that, you can create multiple charts here, drag and drop, select the columns you want to display, and you will have a beautiful dashboard. One good thing about QuickSight is the capture option. Captures the whole thing as a video, so that in demo you don't have to create again. You can just run this video. Right? You can create more dashboard, more charts, and explore it yourself. So that's it about the demo. There are a few best practices you want to follow. One is make sure all the services are running in the same region, else the data transfer charge will be huge. So first make sure whether all services that you want to use are in the same region. For example, QuickSight is not in all the regions. It's only in 5 or 6 regions, so you might want to use that region itself. Load tar data to S3 so that it loads faster, and you can untar those using an Ec2 instance. Right, and use spot instance to reduce cost up to 90%. Move the tar file once it's loaded and aggregated to S3 Glacier or one zone infrequent access to reduce the cost. Use Athena to query the table if the size is less than 500 GB, and if it's more than 500 GB, use Hue or on EMR. That will turn out to be much cheaper. So that's it. If you have any query, feel free to reach out. Thank you very much.